হ্যাঁ, দেখ ঠিক আছে? ওকে, ওকে।
Yes, sir.
ওকে। Just one point, how to share, I'm checking it, whether my desktop is shared or not.
Okay, sir. Yes,
Is
it is shared, sir. It is
my,
visible, sir.
this slide is visible, embedded
Yes,
security?
yes. Yes, sir. It is visible.
Okay, that's good.
So, good morning to all participants. Respected sir, myself Jailal Sarkar, Department of Computer Science and Engineering. Welcome to our Faculty Development Program on Smart Cities and Internet of Things, sponsored by AICTE ATAL. So today we have a talk based on IoT security by Dr. Bibhash Sen. Dr. Bibhash Sen is the Associate Professor of Department of Computer Science and Engineering, National Institute of Technology, Durgapur, West Bengal. He obtained his MTech from Bengal Engineering Science University, Shibpur, India, and PhD from Indian Institute of Engineering Science and Technology, IIST Shibpur. As per the report published by Stanford University, he has been recognized as top 2% of the researcher for the year of 2020. I heartily welcome, sir. So now I would like to request Dr. Bibhash Sen, sir, to kindly deliver your lecture, sir. Sir, please come forward.
Thank you. Just 1 minute, I'm starting it again. One more. Okay, let's start. First, I'm sharing my contents. I think is visible to all of you. So it's visible.
It is visible, sir.
Okay. So good morning to all of you. Hope already the session is continued for others, other participants and other candidates also delivered. Today, we are going to discuss one of the critical issue, and this is the actually most important topics, as I can say. It is the most, you can say, least researched area. That means so much research on this domain is needed for ensure the application. That means the safety of this IoT application. What happened that after the inventions, or you can say the generations of the IoT, it was found that mostly, or you can say generally, we found that most of the times that already we bother about the development of the product instead of what is the security it is providing or something else. At this moment, we don't have any idea whether that product or what is the IoT application will face some situation or not, because we are now focusing how IoT can be applied in the different domain or different application in this area. So that's why now we are focusing mostly application, because this 1999, mostly 10 years or to 15 years before, the IoT emerges, and last consecutive 5 years you will find that consecutive the expansion of the IoTs. So we are not as expected that IoT, the security will face. But what happened that whenever any application is applied in our life, consecutively you'll find that we will get a situation when this phenomena will come. Is phenomena I am telling that here in these cases that most of the applications of the IoT are now facing the situation of the security. So I'm telling that the term Internet of Things was given by Kevin Aston. I think other lectures you know this is 1999 or you can come 2000. So 20 years before the term was introduced and is a uniquely identifiable object. This is the main thing, uniquely identifiable object. And most of the time, these things has some rigorous issue whether this identifiable is possible in authenticity and the virtual representation in internet-like structure. So most of the IoT sector now booming part is the retail. Whatever you will find mostly this application now food I am telling that not food application or food some barcode I am telling that even you are giving some uh,
तो फर्स्ट सेम का ओरिएंटेशन स्टार्ट हो गया है ना
hello Mr. Kamal Kishore anything
Yes,
you
sir.
would like
It
to
is
say?
already. It is,
अब यहाँ पे तो थोड़ा सा और ध्यान से देखो अब
Kamal
यहाँ
Kishore
से
would you like to ask
ओरिएंटेशन
question
देखो
otherwise
Mr.
can you
क्या
switch off or mute your speaker so that I can continue?
कैलकुलेट
Mr. Kamal Kishore, please mute your speaker.
लेंथ ऑफ दिस बार इज
Okay, so
Okay, sir, you can proceed.
yeah, so that is the one of the issues that now and after the COVID area, yeah, in this COVID, you know, the education area also tremendously impacted by this situation. And now applications IoT has emerges and lot of application you'll find. I think already in the different sessions of the IoT you have found this point. So I am going to particularly where my lecture will start. You will find that in the offices, securities for energy, the cost of expenditure, comparing the home, that means core automation security, whatever the $1 billion expenses is coming to the market. And the factories particularly, you will find that these are the $1 trillion money will be spent. That means nine setting gave us this cross sector view, the cross sector view, a total potential impact. That means 3.9 trillion to 11 billion per year in 2025. So that is the huge cost estimated or you have to incur for the different applications of the IoT in different domain. This is the source collected from the uh, I think one authenticate sites we have collected. They have defined that if these settings of the IoTs continue grow in the 2025 just I mentioned, it will happen that most of the concern will come only the security. But since we are now focusing on the application and very least applications going on the security, so this is the one critical issue we have to now deal. After that, we'll find that what as the opportunity we'll find in the different IoT application in I have found that in 2006, 36 or 15, sorry, 2006, and after 2015, and now 2020, the devices, whatever is appended to our life, the growing rate you can imagine. Now, after 2025, how it will go now, you can imagine that at what position. So, data growing that are rated at 10x and connected device growing at 300%. So these are the all resources integrate that if we don't follow the security measures at this moment of the IoT, it will be a collateral or a catastrophic effect in the near future. That's why in this session, we will highlight what are the things we have to consider in context of the IoT. So again, IoT hampers are bringing everyday states together. That is the extension of the connectivity. And very important character there, IoT devices changes state dynamically. That is the very critical, whichever some application, other application, you didn't find it. And diversity in IoT is a key characteristics because it is not just like a medical application. Everywhere now you will find from healthcare to your education to agriculture to automobile, everywhere you will find the main IoT nature. That's why it is application area also diversified and the number of connected device as we are predicting the device currently connected to the internet, so it will be huge impact in near future. So here I have found the dynamic nature. This is the very important thing during the design of the product. Application is application domain, very important part. You have to also think about this thing. And also, since the connection will be huge, the network bandwidth is a issue. Though 5G is coming, but even there will be issue. And in 5G, I think comparing China also, India in good position to develop all this area. And from network bandwidth, there's a big critical issue. If we imply heavy, that means our conventional, you can say heavy conventional cryptography system will not a feasible solution comparing the bandwidth. So that is the 3 point you have to point out. Now, since limited amount of storage, that is a very important challenge of the IoT, because IoT device is a very limited storage. Sometimes a smart watch cannot contain more than some MB or GB memory. So if you use some smartwatch, and using smartwatch, if you would like to get some application behavior of healthcare monitoring or something else, so that case also you have to remember that the storage limitation is very important criteria for this one. And the processing capability. For the most of the sensor based applications of the IoT, you will find these two constant. Now, with so many devices, authentication and authorization also critical idea. It happened that in your smartphone, a smart home, you have a smart fan, smart AC, smart refrigerator, smart oven, anything, maybe from your car to your desktop, everything. If you are now living in a smart environment, you will find some situation where the critical point will raise a very concern for you, that is impacting the authentication or authorization burden. It's a huge burden, authentication and authorization, also a critical for IoT system. So just as per the direction or towards the direction of the IO conventional cryptography, like symmetric or asymmetric, public or private cryptography. If you think that I will apply same thing, already it was examined, the behavior of the conventional cryptography is very poor in the IoT. That's why I'm telling we have to think some out of the box, or maybe you have to think from outside the conventional, or you can use the conventional, but considering this point, we have to develop. How do you know if your IoT system has been compromised or not? That is the very important point. Often after, whenever you're trying to communicate with some network, maybe your home network, you don't know whether that your smart device, healthcare devices is compromised or not. That means someone has altered or someone has changed the circuitry not to get the information from your site. So these are the different thing you will find. uh, some attacks I have given here, though it is not critically mentioned here, not visible for you also. But I am telling that how can you protect highly complex computing system of the complex, error-prone, possibly malicious communication devices, possibly malicious communication devices. This is coming after the development, or you can say hardware Trojan. That is a very important issue has emerged in the market. That is called hardware Trojan. Hardware Trojan, you just for the time being in this context, I am telling that it is a malicious circuit intentionally embedded in your digital circuit, but it will not impact your normal behavior until or unless it is not triggered with some special input. And that is always kept confidential and controlled by the hackers, or you can say intruders, who actually trigger the effect. Whenever it will trigger, that Trojan circuit will be activated. That time, your normal behavior of the circuit will be hampered. That one of the best example for this I am telling. Recently, few years before, in Syria attack, what happened that the radar of the Syria was controlled by anyhow anyway with the applications of I think some Trojan. How? Maybe some Israel secret agency, they have what they have done, they have embedded Trojan in third party anyhow from where the Syria has that means purchased the devices, the radar, and for certain moment or certain time, that Trojan was activated, which suddenly for few minutes the radar activity was disturbed, and within the few minutes that the missile bomber or the whatever fighter plane enter to the Syria sky, and they have done the catastrophic damage whatever they have to do, and after few minutes again radar was activated. But what happened that time? First, the Trojan of the impact was critically realized that if someone has already embedded the circuit which is not known earlier, but due to some timestamp or maybe some input it is triggered, a lot of catastrophic effect will happen. So that is the malicious communicating devices. We have to identify it whether it is there or not, and built under extremely aggressive time to market requirement. That is the very important point. That means we need any device immediately without proper security measures. Also sometimes some companies are launching the devices. I don't know whether their data accuracy is perfect or not, and whether the data is not compromised or not. Now we demand today I need this, immediately I need this. If any company launch it, we purchase it. So what happened? All the companies are now going for this mouse race, or you can say rat race, anyhow to win the market. And that is the extremely aggressive market is found in the IoT application. These all concludes that we have to think the securities today. What happened that first of the security is concerned that if you go for the pre-silicon, that means before the fabrication part, this is the scene. That means is the up to design phase you are designing. Then once the this design has developed, then you have to go for the validation. You remember that one two term in our software engineering, there is a verification and another part is the validation. So if you go for the verification during the development we follow, and this is the after development, you can say follow from the customer side. So in the verification part you will find that the whenever we validate the security also before the development, the architecture, threat modeling, security test, plan, and architecture, all these you have to consider during the pre-silicon. That means the design, whatever you develop, you have to apply it. First of all, you have to apply it in your area so that automatically it can test before the fabrication. What happened during the fabrication? Most of the fabrication is offshore activity. It is not in our activity, so we give third party vendor to fabricate, maybe Vietnam, maybe China, maybe Singapore, maybe any European countries. So after the fabrication, whenever we get the chip or get the IC, we don't know whether they have another obfuscated or fabricated in our chip or not. So that is the one of the prime source of introductions of some malicious chip circuit here. So this is a big concern here. Today we have to think, and code review, RTL testing, these all these things we have to embed with the during the chip manufacturing, and fudging the penetration of testing hackathon also we have to perform. So these are the possible solution we can do. So if it is hardware, what is the hardware? Most of the time here, if I say SoC, most of the time I can say it's microcontroller based. Most of the time I am telling, mostly. It is not that it will always then, and you know, microprocessor based. So earlier days, whenever any hardware we are developing for this one, we think about the processor board where there is a microprocessor. In microprocessor, what happened that particularly for timing, I'm giving microprocessor is the CPU which are connected with the other device with some central bus or some communication devices. So you can append as more as supplied provided by the bandwidth, you can append it. That is the in case of microprocessor, you will find in a motherboard microprocessor is there, and RAM, ROM, all these are connected to bus. Sometimes with slotted cable also we are connecting other device like in this way. But in SoC, it may be simple area which is applicable for mobile type application. You'll find that where there is a just microprocessor or processor, I can say the processor, and within the processor you will find some memory, RAM, ROM, all this, but it in a single chip, not like this a isolated or decentralized connection. No, it is in a single chip. All this including the memory processing unit, or you can say analog to digital converter, everything will be single. So that's why we can say system on chip. This is the latest concept on system on chip in the market is evolved. So the very important thing, system on chip. And since this is an emerging trend on system on chip, now if someone do some malicious act with the system on chip, the entire system will be hampered. So that's why due to the demand of the society also, we have to now incorporate this one. But in both the cases, what are the technology? Hardware is the main root of trust. That we have to know that is these are authentic. I don't know whether this is authentic or not, but we have to rely. Root of trust is always hardware. Software can be reprogrammed, software reprogram can be redesigned or something and easily, but it compared the hardware. So that's why we assume that hardware is a mostly authentic. And the most interesting feature is that in the IoT, most of the IoT's performance rely on the hardware because very small scale programming is introduced here. And the main environment, that means IoT devices, the reaction with the environment is the very important. That means whenever you senses some data, process it and give the output of the data. So the sensing and actuators, so both are simultaneously you have to control, and that is only software it cannot be possible. That's why in IoT's application, hardware plays a very important role. So what are the attacks on the hardware Trojan is found? Already I have shown that AES encryption techniques with the more latest advanced encryption system also in under attack. It is found. It's a one example I have shown. Slingshot APT riding on a hardware Trojan horse. That is the hardware Trojan effect. And in a particular 12 million fake phones are found. You don't know whether the phone you are using as a fake or not. Nowadays, it is a big concern. In Dubai, they found 12 million fake phones they have already captured. So all these are fake phones. That means working as a phone, but their chip or their IC or digital circuit is fully compromised. So like in this way, different attacks we have found here, and which also gives the importance of this IoT. Now, if I conclude again the statement whatever discussed so far, I found that IoT increase the number of threats. That is the one big concern. Distributed IC supply chain, because I told that it is not possible to design or develop or everywhere IoT fabrication IoT. Not possible from your side due to the cost and the other parameters. So it happened that the IC is mostly distributed everywhere. So that is the vulnerable security threats. Security system relies on storage of secret key. That is the main thing, storage of secret key. If something is storage, so there is a chance to steal from the store, and stealing of the store, so you can't imagine that how intruder will do. So current conventional system which has some secrecy, that is the storage key, if anyone you can breach, this is the problem we can do. Storage device is susceptible to invasive attack. That is also a very important thing, because easily you can do because it is physically available. Current security system is not testable or feasible for the resource constrained IoT. Already I have told the memory and bandwidth is a big critical issues for the sensors. So now what will go to rethink for this process, that I'll go for this way. So requires we requires a lightweight security primitive. The lightweight in the sense I am telling that take very less memory. Takes very less memory, one criteria. Energy consumption big will be very less. That means you can say low power technology. Low power technology is required because most of the IoT which is battery backed, you can say it is battery backed devices, require that our crypto system should take minimum less amount of memory or less amount of power, so that energy preservation is possible. First of all, and mostly you'll find that all are app based applications and modules are coming. So these two important criteria we have to design during the development of the IoT. And most of all also no storage concept. So that is the trends. Already I have explained the way of the install border worldwide from this one. So affordable IoT devices won't use such chip, meaning that there is a need for better approach. Because those chips, whatever I am telling, the chips with storing some information cannot be done. The problem is with modern architecture of the chip made specially for the IoT devices, the price will go up, make them expensive. So we have to think less expensive also. Like in this way, basically the many IoT devices lacks in cyber security protection, such as strong default password. They often leave interconnected system vulnerable. During the reset of the even our router also, some default passwords are there, which is available in the ROM. So this is the one of the cyber security big threat, that anyone can take the router control easily once they get the key. So this way we'll now conclude that how to secure authenticate devices. That means the cars, RFID, mobile phones, all these things. Genuine electric versus counterfeits, whether it is a fake or not, there is a big issues. How to protect sensitive IP on devices, some digital content, personal information, software, mobile systems. These are the very important criteria. How to securely communicate with the devices, private and authentic communication channel. We have to also think about this matter. So we found that computer devices are becoming distributed. This is the main, very important in context of IoT. Mostly they are not centrally, they are distributed context. Very important part. And unsupervised, once they are, that means delivered, or you can say installed, because some weather sensing IoT devices is completely exposed to the environment. And it is not there that we will go and everywhere have to check the devices are protected from outside. So we will not supervise some open friendly environment IoT devices and physically exposed. That is the very important parameter. So computers on the internet, that is the also untrusted owners. Embedded devices like cars, home appliances, that's also a big channels, and now mobile devices. Attacker can physically tamper. Physically tamper, I am telling that uh, they can break the chip, reverse engineering, and they can make a clone. So how I can distinguish that my original chip from this clone? So invasive probing, non-invasive measurement, install malicious software. These are way they can directly contact with the physical hardware. So now, which the root of trust, or the hardware was root of trust. Now this also under attack. So earlier days, whenever any conventional cryptography was built up fully software, thinking that, relying that the hardware is secure, but nowadays hardware itself not secure. So software only protection nowadays not enough. That is the conclusion of this first part, that it is not secure. Though so many challenges already we have found, the IoT encryption, IoT authentication, and security is the trend, the growth rate comparing others. You just imagine how we are going toward this. So we have to face some critical issue. So what is the now solution available? There is the all problem still we faced. Lot of problem I have discussed till this last 20 minutes I have discussed. Now my question, how to solve this thing? So a traditional solution is the authentication example. Each IC needs to be unique. That is the first part we have to follow. So embedded a unique secret key on in chips of non-volatile memory. But again, I am telling this under attack. So very important point. Use cryptography to authenticate an IC. Okay, very good. Now you are using conventional cryptography. In very beginning, I am telling that this is not suitable for our IoT. But even nowadays, using a verifier sends a random chosen number. The IC signs the number using a secret key so that the verifier can shoot that the IC possesses the secret key. Otherwise, not possible. cryptographic operation can address the problems such as protecting IP of secure communication. So cryptography operation can address other problems. So thus it is found that IC with a secret key, it is available, sends a random number server to the ICs. If the secret key is available, it can decrypt or it can sign it or it can do that necessary modification and send to the acknowledgement to the server. So they can realize, yes, it has that key, only that secret key it can do. So during the transition number, after a lot of multiple transaction, there is a possibility of model, or you can say modeling attack to ensure this. But even it was now using tamper-proof packages, that means sensor to detect attack, that is very expensive. IBM 4758 was introduced, continually battery powered. So that is the another critical issue. Not I can apply to the IoT devices, because a sensor which costs 300 or 400 rupees and the devices which cost 600 or 7,000 rupees to protection. So I think you can't imagine that cannot be suitable for this IoT application. At least the security measure should be less than 300. Trusted platform module TPM, that a separate chip for the security function. Nowadays, still it is in our CPU, or you can say our desktop computer, laptop computer. This concept is still used. A separate chip TPM is used. So decrypted secondary keys can be read out from this bus also, another critical issue, but is available still now. So this is the existing system. Now in the existing system, what happened? Found that whenever you convince some message to the maybe devices or particular chip, so what happened that you are encrypted with some key and decrypted with some other key, so they can read the message. So what happened that if hacker can read the information, anyhow the side channel is the real world situation, that they will analyze the data. I will show you that how side channel can get the keys or information through which it can happen, through which a cryptographic model leaks information to his environment unintentionally. It is not intentionally. Unintentionally they can leak. This is a very critical issue nowadays found. So cryptographic theory has some limitation, that there fully relies on the keys. If someone can get the keys, so the algorithm does not have so much secrecy. Only the secrecy is the main thing. So there is the absence of theory for the reality. That means real life what happened we don't know. So even mathematically strong cipher leak in the real world. That is the very astonishing characteristics. So what happened there? Whenever we go for the IP from third party or tools from the another third parties also, and standards, whatever maybe, these are the big concern that is developed by the third party. Also the fabrication part which goes to the offshore, that is the another issue, and packaged not really trusted. So these are the three very important issues, are the untrusted area where the security breach will happen. So threat at different stages of design and manufacture flow. So this is the happen. I am not telling that after the specification design all this thing, during the design also, whatever if third party IP code is used or standard cells or some tools are used, if the tools have some breach, because these are mostly whatever simulator tools or you are making, all are dependent on the third party. So there is also a possibility of breach. And also packaged not really trusted, because in the fabrication part you don't know what happened. So that's why we now focusing that everything in this area will be contacts. How about for the side channel attack? Just now I'm telling, whenever any transaction is going on, maybe multiple transaction, just like ATM or something, in a ATM card chip is there. So you are providing some data, and chip will verify, they'll give the data output. So if you have some tools to analyze the power consumption, so if you notice it, that the power consumption, normal CRT also can do this thing. You will find that where some information of breach are there, so they will consider one. If there is automatically there is no spark at the middle of the transaction, they'll consider it is zero, it is zero, it is one. So based on the timestamp, the power consumption, they can assume that this is the secret key for this transaction. So if once they get it, rest of the things nothing else. So they can decrypt this part and can steal the information. So side channel that if they embedded some device here, small device like a skimmer like device, skimmer they are taking the images, but I'm not taking the images. Suppose the image also not there, chip itself has the secrecy. So only password not possible, that chip has some unique identification if you can detect it. So that's why some device we are embedded which will take during the transaction what is the power transition, because everywhere whenever logic verification takes place there is a switching activity, and for this some power consumption or power distribution takes place. If we can measure the power consumptions, so you can guess the information. So that's a very critical issue, everywhere it is possible. So for that purpose, in what the IoT connection, many IoT uses will involve in ensemble of devices, secure device to device pairing and communication. So that's why a trustworthy and flexible grouping is very important things. And also whenever usability of the key, eliminate need for manual configuration. Every time after the use of the key, you have to throw the key for timestamp, or intuitive system administer seamless for normal user. So that will not be at this moment will be very suitable for us, or we have to rethink for this one. So how can I do? How to generate and store secret key on IC? That is the thing. I will generate and store secret key IC in a secure and inexpensive way. Secrecy is always there. Secrecy I have to, but that I am storing it is secure, that there is no way to extract. That means adversaries may physically extract keys but from non-volatile memory, but trusted party must embed and test secret keys in a secure location that adversary can attack. EPRIM adds additional complexity in the manufacturing if you do this way. What if cryptography is not available? If I thinking that cryptography is a burden for my devices, so extremely resource constant system such as RFIDs where this type of thing cannot be applied. Maybe in banking system cryptography is okay, but for a barcode reader or for a scanning in our FASTag in highway, I think that's why cryptography will be very burden for this system. So commodity ICs such as FPGAs, all these things are nowadays not suitable. In this application, what happened? So everywhere we're finding solution, and everywhere we're finding that we are getting some criticality. So what is the current challenges that need to be sorted out? In automation domain, everywhere now doing some automation. So here also, once the controller, attacker adversary take the control of the automation, then entire system can be hampered. So automate during the automation, you have to protect it. Among so many domain, I am concerning only this focusing part. These are the all encryption capabilities, privacy issue, the big concern of the challenges, common framework, because all the IoTs due to the diversified nature and their applications domains is different, their common framework development is a big challenges issue. Data integrity, because sensor, whenever sensor updates some information, it will be congruently or concurrently update the server also. So these are the different challenging point you have to sort it out. We are focusing from today's lecture the security concern of the IoT's application, how we have to ensure the security. Now extract secret from the complex physical system, we use this path. So a new technology evolved in the market, and you can't imagine already we have implemented and developed, and we found the suitability of the path, not on the our side also. SIL, one very prominent laboratory of IIT KGP, we have got lot of help from their side in different knowledge sharing or understanding. So more few slides also we have collected from that laboratory also. I will show. Professor Devadi Mukhopadhyay, one of the very eminent personality in the field of this one, Raja Subra Chakraborty also, and we have got tremendous help from their side to develop this type of applications in our NIT's campus, and also we have developed successfully. So today, now we are entering the domain So extract secrets from a complex physical systems. So we acknowledges the contribution of the slides or some knowledge from the cell laboratory of IIT. So because of random process variation, no two integrated circuit, even with the same layers of identical process, we that means no two integrated circuit, even with the same layers. I am telling that maybe you have developed one multiplexer using same, other person also multiplexer, twisted multiplexer, both same, but there should be some unique characteristic. Functionality is same. I am not telling about the functionality. I have to find out some variation that is inherent, very important characteristic. Even they are fabricated same machine, same company, same environment, same way, there is a physical variation, and that is the inherent capability of the silicon. Hard to remove and hard to predict. You can't remove it, you can't predict it. That is the physical invariation of the silicon. Relative variation increases, that is increases as the fabrication process advances. So you will find some concept of the puff, my consecutive slides. Suppose what is puff? You can say it may be hardware hash function. That is secret, can't explore by you. So hardware hash, remember I'm not telling hash, hardware hash. So uniquely identify a device. Uniquely they can identify a device. That is the very important thing. Uniquely identify a device. Impossible to reverse engineer. That is the main thing or main advantage of this array. It is impossible to your side that you can do reverse engineer. If you do some reverse engineering by modeling attack or power spectrum analysis, anyhow, anyway, it's not possible. I will show you how modeling attack also affecting nowadays. Application now, since it is on chip application, on chip, no external software or anything is required. The on chip application and completely hardware oriented. So RFID chip authentication everywhere in IoT devices, it will be very suitable to apply. So what can I say now? Conclude the puff. It is a fingerprint of a devices. That means you can uniquely identify. In classically, whenever your thumb is given to your biometric devices, the informations are checked and authenticity is probed. Same way, the silicon devices, that puff will perform inside that fingerprint and your authenticity will be guaranteed by the puff. So you will give a challenge. A challenge means some input. I am telling challenge, some input, and you will get some response, that is some output. The input and output, if you have predefined input output, you know what you will get. So automatically you can check. Very interestingly, you found that the same input, if you give it to the same chip also, in the power oriented circuit, the response we have some differences because it is completely depend on the silicon's physical behavior. It should not be same. So that's why challenge response mapping is ideally unclonable and instance specific. So path is emerged is one of the suitable example is a highly secure. It can generate a unique secret ID, and is a highly secure, volatile secrets. No need for trusting programming, or it is that after once you give this challenge, at this moment it is coming, next time it may not come. So a set of challenge and response, I don't think anyone will come. You don't know at this moment what will come. And that is only kept by the authenticity or the validator. You don't know outside. So if you even know the challenge and response for this time, this challenge will give this response. Next time, this challenge will give other response also. So it is a inexpensive, no special fabrication techniques. Path can be, and you can say it's available or ensure secure low cost authenticity. So if I would like to show actual view of the path, that means how we can say that is working. Just 1 minute. I am starting some video. Is this visible to you?
Yes, sir, it is visible.
Is this video is visible?
Yes, sir.
I am asking, is this video is visible to all of you?
Yes, sir.
Yes, sir.
Anyone?
Yes, sir.
Anyone can reply?
Hello, sir.
I am showing some
Yes, sir.
video, whether it is visible or not.
Yes, sir. It is visible.
Started.
Can
Yes, sir,
anyone
it is
is there?
visible. It is visible to us. Clearly visible to us, sir. Hello.
Yes, sir.
Yes, sir, it is visible.
Anyone is there?
Visible.
Hello?
Hello,
Am I
hello.
audible, participants?
Yeah, you are audible, sir. You are clearly audible.
I am not getting your audio.
You are clearly audible, sir.
Dr. Abhishek, are you here listening?
Sir, clearly audible. Hello.
Hello? Oh, I am not listening you.
Hello.
Okay, okay. I'm checking it. What happened? I'm not getting anyone voice. Okay, sure, sure. If you're getting any, you can apply chat box also to get me. Okay, sure. Okay, sorry. Actually, you people are listening, but I am not listening you. I don't know what happened. Okay, that's no problem. Maybe some microphone setting I have to do. Okay. So I am showing this video just little bit. Actually, how does puff looks? You'll find that in the fabrication process, this is my actual circuit. Actually, this is my actual circuit. Puff is a additional circuit, not within the circuit. Puff is the additional circuit. It is not uh, for my functionality of any circuit. I will take puff for my security purpose. What happen? It will be embedded within the circuit and then it will be fabricated. After the fabrication, the devices which has come to the market, I know my puff circuited, and consequently using the puff circuited challenge response pair, I will check it. I will give the response to the circuit channel. Intruders, this is completely unaware of the intruders. They can't find it. Only when I will find the response is the behavior uniquely from my database, I can understand. So it is a additional circuit embedded within the you can say our part. Okay. Again, I am come to the my circuit. So it's a volatile secret. Okay. So since it's a volatile secret, so how we can ensure this circuit? Today our target will be that I have to embed this volatile circuit within this circuit. Okay. So first of all, we go for that purpose. Now you'll find like in this way. See what happened. I am generating some inverter chain. This is for only oscillations purpose. What happened that if I give 0 here, now 0 will be 1, 1 will be 0, 0 will be 1. Like in this way, here will be 1, 0, 1. Now when this will reach here, it is enabled, that time this will be given. When this will be given, event data is available, but it can't predict it. Issue is that the propagation delay and the circuit is coming if that introduce the delay particular at what time this will come and not. So what happen? I gradually if sometimes 1 1 will happen both cases, sometimes 0 0, sometimes like in this way. But there is a particular delay. Due to the propagation delay, you will find that when the clock is 1, I will get sometimes 1. Even clock is 1, I will sometimes get 0. You can't predict due to the delay of the propagation. So this is the main thing we are here focusing the delay of the circuit. So delay based. If I can introduce the delay or you can utilize the delay. So at what time for the intruder, they don't know that 1 is the given input for the clock, even sometimes output 1, sometimes 0. They can't guess is 1 at what time it will be available. After that also saying in ring oscillator widely used in ICs to generate clock or characterize the performance in the ring oscillators. So here even numbers of inverters are there and you'll get a certain output, but whenever you give the feedback and also after some time the predicted output at the time you can't guess. So ring oscillators are widely used in ICs to generate clocks or characterize the performance. So each ring oscillator has a unique frequency, even if many oscillators are fabricated the same mark, but they have unique frequency. So that is the one foundation stones which has give the exploration of the circuit. Now you come to the point. This cases the puff circuit using ring oscillator. Here also by some input, actually the oscillators are coming output, the input, but based on the input we are controlling or taking the output some circuits and comparing the outputs are getting outputs of the two oscillators of the counter. We can generate the randomly bit from top or bottom, anything we can get the output. So for different set of inputs we can generate different outputs, and that is also completely unpredictable. Why? Because of that purpose, the input bit whatever you are using, and based on that they will select the random signal. Even if it is select for all zeros, the beat pattern of the all zero due to the oscillation also will a variation will be there. So you will find a in exponential challenge response pair for a particular circuit. So it is not so easy by the any hacker to guess it. Now we go more details on this part. So all ring oscillator must be identical. Any ring oscillator design will work. So no additional constant required. Everything is standard digital logic. So that is the main advantage. No placements or routing will be there. There is no placement or routing constant outside the oscillators. Can be implemented even on standard FPGA. So that is the very important that so far we have developed. So there is no replacement or routing constants are there, and identical layouts are there for each challenges. Now you will find that PUF response is used as a random seed to private public key generation algorithm. Random seed. So if some conventional ECGs are used also for generate the PUF secret seed, then private key concept key generation. So using that PUF, now you can generate the public key, and that is the main randomness you are into the public key. So PUF response is used as a random seed to private and public key generation algorithm, and here this is completely untraceable. So no secret need to be handled by the manufacturer. Manufacturer nothing have to store or manage. Automatically it will manage by the on-chip circuit. A device generate a key pair on chip and outputs a public key. The public key can be endorsed at any time. So now we are striving to this part. Suppose now we are some just even untrusted supply chain in the environment they are doing the pub generate. We are now authenticate that if I will from the challenge response whatever I have during the fabrication design, I know this is my pub circuit I have already embedded with this one. So for that pub circuit I have some challenge response pair which is in my pocket or within my devices. Now if someone has cloned my circuit, suppose someone has cloned my circuit, so what should I do? I will give to check the authenticity, I will give one challenge, and since this path is a clone one not original one, the response which will come will not match with my circuit. So automatically I can detect this part. Just 1 minute. So that is the one of the low cost authentications found. After that, challenge response pair. What if an attacker obtains all responses and put them into fake chip with memory? There must be lots of challenge response pair. Use different parts on FPGA. Use configure delay paths for the ASICs. Use configure parts on the relay of the parts ASICs. How to do? There must be lots of challenge response pair. Use different pairs on FPGA. I told them lots of challenge response pair if PUF is embedded in the oscillation scheme. So if they develop the same thing also, I tell them that what if an attacker obtains all response and put them in a fake chip? They got all responses. So there must be lots of challenges where use different parts of FPG. So use configurable delay path on this ASIC. There are also solution. Now we'll show configurable delay based some architecture that is also very important, and we have worked on these things. What is the configurable del? That now the after challenging we are configuring bits. If I give 001, if I give 101, or if I give 110, the path, the circuit, whatever will travel will differ. Now this path is traveling like in this way, 00 application of 001, but if you give 1 or 0, the this path will follow another path. So path is completely now changing. That means compare two paths with some identical delay in design, the random process, whatever I am selling this random process. So this randomness now will differ, completely differ. In earlier cases, if I now we traverse this way, this path, after the challenge bit, it may happen that I am traversing maybe this path. So since the path will differ, automatically the delay as usual, all these things will happen. So even if we go for the identical delay in design, random process variation determine which path is faster, and arbiter outputs of one way digital response accordingly. So multiple bits can be obtained by either duplicating the circuit or use different challenges. So each challenge selects a unique pair of delay paths. So configuration bit will completely control this unique pair of delay path. So now our target that we have to introduce this one. So what we found that even the challenge response pair is reproducible, but it is unique for this chip. Then also uniqueness that even two paths are designed in the same fabrication, their response will not be same. I am telling that same path circuit, the path 1, path 2. If you develop the path 1 and path 2, if you develop the same, if you give the same challenge, their response will be different due to this silicon fabrication variation I told. So a clone path, that means legitimate path can be distinguished based on their response. So that's why it is unclonable. You can't clone it. Though some exception I found, some SRAM or some small scale application of the path, we found some modeling attack, machine learning attack recently introduced, and they have built some uniqueness, but still it is found that is very rare, 0.0001% chance to get that clonability. But in STM application is found. I am not getting that storage application here. It is one way function. That means if you give the challenge, you'll get the response. But if you do the response inverse function to get the challenge, not possible. So if you know the response also, you can generate the challenge. And for a given challenge, the response also you can predict uniquely. So anyhow, the legitimate path and tempered path can be uniquely identified. So intrinsic property to device use the generate key. I am mostly giving the different path circuit in found that delay based path, memory path. These are the different path we found, glitch
Sorry,
path,
what do you
and
benefit
in
for
the
sir? We
non-silicon path,
also wrote
optical path, acoustic path,
what is
coating path. These are
many
the UA
PhDs
paths.
comes awarded.
Mostly we are
Uh,
working on this domain of the delay path by using arbiter and no path. I told that this path has some limitations. Is a sometimes someone has proved that it can be cloned, but at certain small scale level and low. So the actual path property cannot be. An arbiter path has, due to their exponential challenge response where it is really tedious task. So that is the arbiter path. I already mentioned that during the switching bit path configuration, I can configure the bit dynamically. So it may be my challenge will perform the selection of the by. Here my challenge will actually do the necessary uh, switching will take place, and finally based on the delay the latch will generate the responses. Some STM cells are there, some butterfly fluff, some ring oscillators. Using some challenges we will take different configuration bit. These are the possible existing paths are there in the markets. So already I have shown that path circuit can be used for the key generation in ECC based concept with the hashing. That is the one application, and also path authenticate video can be done here. After that, nowadays in market, Altera, FPGA, these are the different concepts are evolved in the market. So FPGA has become an attractive platform for faster growth of the IoT. So if we can reconfigure the FPGA to meet the design goal, so that is the one point. Since IoT fully depend on the FPGA nowadays, and fully not, I can say most devices are developed by FPGA, and FPGA configure that was PUF implementation. FPGA was comparatively easy, so PUF can provide the low cost security for all of us. So how I have implemented, I have related works we have studied so far. You can say so. We have first performed the list based CRO. In the configurable CRO, use a multiplexer to increase the number of configuration. So lack of flexibility and area utilization can be improved. So in this case, ring oscillator path is the most suitable path and very to implement the FPGA platform. So in FPGA, the ring oscillator, the sensitive to environmental variation. The main problem of the RO path is that it is it is completely sensitive to environmental variation. So we have to design the RO path in such a way that it will not impact due to the voltage fluctuation or temperature variation of the environment. That's why we have configured. Someone has some multiplexer. We have considered say latch. We have considered and flexibility to provide. Instead of that, this one latch will perform most secure way. So we have introduced some D latches here to get the prominent delay of the circuit, and also during the configurations bit, the I have routed to the part in the different angle. Now this way for different channels, same for this way routed will be finally comes out. So is a use a transparent latch instead of inverter. I have not used inverter, has a latch, and due to the clocks also as well as the synchronous circuit, the free resources are utilized to increase the number of RO configuration. Free resource that on LOT. If you think in the FPGA will find some lookup table like a decoder circuit or system memory, where from the decoder circuit you will take the input, read some marks based applications are there. Directly you can read the input to the marks, or you can store in the flip block to go there. And now if you give 0, then this output will directly comes out. If you configure bit 1, it will comes out, the latch based circuit output will come out. So that where I will give the input or store the input as per my logic. If I can say I have to develop a AND logic, A, B, you know 0001 1011. So what is the AND logic of the AB? A and B 0001. I will give the lookup table this bit. So 0001 will be stored in the lookup table. Now from the lookup table, the data will be read as per your configuration. That means whenever you have to read the 0, you have to apply the marks. You will get the output from the uh, bit 0. So based what happened that here you are playing in some marks and configure. If you give 00, this bit will be read. If you give 01, this bit. If you give 1 0, this one. If you give 1 1, this bit will be read by the circuit. So based on the configuration of the corresponding output, I directly it comes out, or maybe through latch it will comes out, and that also configured by this circuit 0 or 1. So that I have applied here. Nothing new thing, but only that latch will control the now delay. The it is a proposed design may contain odd as well as even number of delay units. So no restriction. Only neighboring arrows are compared with the reduced bias. So bias is another important thing, that the number of occurrence of 0 and 1 should be always 50-50. If only one more one was present and 0, then it will be very easy to guess for the intruder. So that is the one thing we have not done. So this is implemented on Xilinx Spartan board circuit. We have implemented the proposed design. We implemented using Xilinx Spartan 3A. Nowadays not is most, though we have also implemented RT6 also, the latest technology. FPGA using Spartan 3 starter board, and LCRO with 3 switch block is implemented inside the single CLB architecture. If you go for the CLB or FPGA architecture, you'll find that most of the logical implementation is done by the CLB part, and there is the SB switching board, which will actually connect to CLBs among the route the information within the FPGA. To make each LCRO symmetric, it has been implemented as a hard macro. In implement hard macro, 64 different RO configurations are possible from a single LCRO. Now, implementation of the proposed design. 100 similar LC rules are created by introducing a hard macro. Now, once we develop and such type of 100 macros we embedded within the Cs and placed in a 10 by 10 matrix middle in the FPGA. Your FPGA circuit worksman different to any other functionality you implement, but besides that, I am telling that some portion of the FPGA I have used to develop my part. Maybe other logic function you are implementing here, no problem, and that is my purpose. Once this chip will be used for an IoT devices, so I can use that path for authenticity, and that I am showing here how I am implementing. So 99 reliable response which can be extended from 100 LCRO. So that is the one prominent case is not easily guessed. So that we have done in the developer laboratory. What I am showing that initially in the FPGA level using some Xilinx ISC, we programmed the Verilog code, and after Verilog code we developed on our FPGA board that we have developed, and this FPGA function running properly. Also during the FPGA, what happened, we have checked different voltage we had applied using some voltage amplifier, and we check the response differences from the circuit. After that, hot air gun, this is the hot air gun we have applied and get the temperatures or variation from this one, and finally that we measure the temperature also and check that in the temperature variation also path should work. So that we have done for temperature variation and voltage variation also we have checked. Within these two also we found the experimental nature, that the variation of the chip, the design, whatever output we are getting, that configuration in for particular frequency we have measured, and with different board we have considered in a multiple board with multiple CRT have configured and we have checked. So it is found 20 similar Spartan 3 board we have considered. So their challenges must be same but should not be same due to this path circuit and intrinsic variation of the chip. So 5 board measurement is taken in different temperature and voltage also. We have variated the temperature and voltage and check the path input output. A significant change in frequency has been observed when the number of latches varies. That is the very important thing. When the number of latches, that means if I select odd number of latches or even number of latches by the selection, we found that frequency has been changed. The selected stable arrow configuration are most random. So that we have analyzed here. In the histogram for bit aliasing is found, or the probability of occurrences in the bit percentage we have shown here. Also, uniformity, the occurrences of 0 as 1. I am telling that zero, a number of zero is one in your response bit, we found mostly it is towards 50-50. That means if you have 8-bit circuit, you will find this situation mostly in these cases. So 4-1, maybe 5-0. So 4-0-4-1. So sometimes maybe like in this way, sometime maybe 5-1-3-0. But it is mostly you found towards the 50%. So that is the ideal value of bit-aliasing infinity is 50% that we have received in every cases. So bit-aliasing value tends to the ideal value 50% with a high probability, and on average is 49.65, so very close to our target value we found. And the variation of the standard only 3.78 deviation we found from the uniqueness of this property. So from these assurances, we have different voltage we have applied in the different board. You get the variations comparing the board is very less, and found that our architecture is more stable. So reliability is high for the delay unit we found. In case of our ledge weight, it is found 99.49 after the introduction of the latches. So reliability indicates the stability ideally should be 100%, and we are very close to the 100% wave. So the board responses with different temperatures and different benches we have performed, and these are the different voltage we have considered. You can practice or try for this one laboratory, and these are the different temperature also we have performed, and under this different temperature variation we notice all those features. So the temperature variation did not affect the reliability. That is the important point that I found in these cases after variation the temperature. And on average, the reliability against variation is this with a maximum and minimum value of this respectively. So we are approached toward this, the average we are considering. So this very reliable circuit we have designed. So like with this is, so it's a security primitive. So now it is a reducing cost. So world without path, what happened? Either we have to use the third party's non-volatile memory that is attackable or attacked by the users completely vulnerable. EPROM adds additional complexity to the manufacturing. If you are using some EPROM based circuit, adversary may physically extract secret key from the non-volatile memory, even reducing the cost, but raising the security world with the PUF. What intrinsic properties of devices is used to generate key? So only the chip's physical variation, intrinsic property, which is always present within the chip due to silicon-based chip. So we are just utilizing the variation of the silicon's property. So key never lives in the ICs and cryptographic boundary, nor be stored in the knowledge. So there is no storage of any secrecy. Only is that the challenge was kept with us, not in the secret is stored on the key chip. We are not storing. Key is deleted after uses or decryption process, because for this correction you have infinite number of combinations, so you can do exponential. So I can say infinite. So the response, if I go mix with the IoT, the response have to be unpredictable. That is a good thing. We can do that. Should not be able to model, is not easy to model. That means just predicting or utilizing that all the challenge response pair, you can't generate a mathematical model. The response should also be unique and independent. That is known from one response should not leak the output of the circuit. So now in Wi-Fi application of the authentication, I am giving that MAC proofing, event twin, or some RAJ API, whatever may be access pointer we can access. All these attack are happen in case of our that means IoT application. We can now prevent all these IoT application by extracting the key stored only the three challenge key pair with the helper triplets in the database of the server, allowing the MAC address. Now, if the database of the server is hacked, there is an issue. But comparing the sensor, what is openly environment, we are not storing here. We are actually preserving this effect. Now, whenever any challenge will be given to the PUF embedded circuit in the IoT devices where PUF is already embedded, it will give some response. From the response, our using fuzzy extractor, we will extract the key and the helper data. So that will be available in the particularly challenge response pair we will get from here. So we can get the data from here. So one time enrollment phase will happen. Initial cases, that key in the router there will match and we can authenticate, yes, this is the genuine devices. If this is not the puff circuit, the response whatever kind after fuzzy extraction, this pair of the helper data will cannot be created. So once the IoT devices, maybe from MAC address to the router, will check the router database, and finally is MAC address ID device present in our database? If yes, then go to authentication phase. That means with my helper data and my response or challenge, now I will try to authenticate device. Yes, because I found whatever the probable device is trying to connect with me, it is known to me at least. So now I'll go for authenticate it. What happened that this is the one protocol we have developed. You can find it out in the websites or web sources available. Here's some algorithm for time limitation. I'm not going more details. Some XOR, simple XOR application we have applied with the routers, and after the key, whatever key or challenge we have pair generate with the some random number, we XOR it and you set of new, because you found it here. After this helper data, a challenge response helper key pair is generated with the helper data. So that challenge response pair will be now utilized for generating the new keys that due to the non-sective that means random number. Now this will be passed to the IoT devices. IoT devices now will, based on this challenge data, they will generate the response. Now, based on the response and the helper data, whatever they send after the fuzzy extractor, they use from the repository using some just whatever they have Q, K3, and if you join K3 and K, the nonce will be generated. By that, the I2 device itself. Once the nonce will be generated, then rest of the challenge key pair will be generated. So checks, you send it, then database whatever I have, and I will compare this if it's same. So it is authenticate, otherwise it is not authenticate. So very simple protocol. There is no huge cryptography happen except some XOR. It's a very lightweight applications. Okay. So IoT devices, some repository I am telling that where actually they convert this circuit from challenge to response. Everywhere there's a pub circuit. So like in this way, there's the one more client authentication phase we have introduced here, and here we have done. I am not going more details. You can find out in our papers that we have used some protocol, and the using this protocol now this will make light no such huge probability transposition as box which is used in the desk we are not using. So we have enabled the security. After verification also found that even if they know the key or something, the fuzzy extractor will not help you to get. So we found that after generating all these things, that is what we can say semi-invasive property, what we mentioned. The proposed protocol does not store any secret key inside the IoT devices. No secret key they are storing. Whatever data they are coming from the data they are generating the key. So no storing is there. So no invasive or tampering attack can be done. The protocol utilizes PUF generated challenge response. It is PUF based. It is not that I have generated something or you have from stored database they are generating. So that will also attack the MAC address spoofing. Not possible. The value of nonce change during the each new connection. It will be generated random number every time whenever you're trying to generate, even the nonce is captured by the intruder or a hacker, next time it cannot be used because this is every time new connection. Thus Wi-Fi password will also be changed for each new connection. Evil twin attack without knowing the proper challenge response pair in adversary cannot provide its authenticity to IoT devices. It is not possible. He can't generate. So evil twin attack also prohibited by capturing the message during the transmission, cannot guess the actual the knowing the nonce. So in every cases I have given this is the situation in different way. we have already implemented. Yes, sir. So a little bit we are going now hurry. So that is we have implemented in the PAF circuit in the laboratory and we have checked the IoT devices. So that is the already experimental setup. You can generate a synthesis framework for this, and finally we can devise all this processor FPG memory. So nowadays some modeling attack is found that from the data, if we apply this algorithm model building attack, so sometimes using, because due to the upcoming new trends or huge computational performance, you can know the huge data set you generate a model building. So now a test from the machine learning algorithm attempts to develop a model from the observed challenge response pair of the CRP using all the data, because huge data set will help us. So that also we are now mitigating by implementing the restrictions. So these are the way. So finally, I can conclude here that the IoT has no protection against attacks. So seamless information exchange without user intervention we can apply by using this introduction of the PAF circuit. Okay. So securing IoT using PAFs, combining PAF with the public key cryptography, even nowadays now introduced, because fully the protocol for PAF is not developed. So challenge that designing an efficient mathematical proven secure PAF based authentication protocol with an untrusted server. The main challenges we are now all of our world researchers working on this. Combining public key cryptography with the ECGs are now PAFs is most suitable for the IoT's application. That's from my side for today's presentation. So if any questions from your side, I will be highly glad to answer Susbu.
So, dear participants, has there any
I am
question?
not getting your voice. Probably I don't know. Suddenly this happens. I'm checking my audio signals if there is a issues there or not. Just 1 minute.
Okay.
Uh, I think it's better if I.
You can tell now. I'm trying to
Yes.
listen. Yeah,
Yes.
I'm able to listen.
Yes. Thank you so much, sir. So, dear participants, has there any question? You can ask freely to sir. So thank you once again, sir, actually for your wonderful information, sir, and giving us time from your busy schedule. And sir, there is one question, sir. What are the
What are the
cybersecurity
cybersecurity
challenges?
challenges in IoT healthcare? Yeah.
Yes, sir. Yes.
Uh, First challenge in the healthcare is that mainly the devices of the healthcare is coming very sophisticated, so the data should be prevented. First of all, that if we can protect the healthcare devices from the outside intruder to attack, so that is the one thing we have to prevent the attacker to get the data from the healthcare device, like a MRI devices or something where data is stored from the MRI activity, that should be prevented. And most of the fake, sometimes some medical devices are developed is very costly, thousand crore, 1 crore, 2 crore devices. If someone devices the fake devices, so there will be also the breach of information. So fake of the devices, fakeness you can say we have to prevent by the introduction of the PUF. That is the one thing. Now we're working some people in IIT Madras also to secure the healthcare devices particularly to prevent from the attackers.
So thank you so much, sir, for your information about IoT opportunity, attack on hardware, IC to IoT, cyber security threat, security challenges, traditional solution, embedded security gap between theory and practice, threats from side channel attack, PAF application, design of flash-based CRO, and most importantly, sir, your implementation. And thank you once again, sir, for your
So one
presentation.
question has come, just 1 minute.
Yes, sir. Yes, sir.
Sunil, is the if we deployed PUF, then circuit size there any change? No, actually PUF is comparing the FPGA, only 1 or 2 CLVs are using, where here 25, 65, 75, that means in multiples of 2, the CLVs are there.